The question reads, a rocket of mass 1000 kg uses 0.5 kg of fuel and oxygen to produce exhaust gases ejected at 5000 meters per second. In the first part, define momentum. We have to define the momentum, and it is a 1 mark answer. So it is a physical quantity which is defined as the product of objects' mass and velocity is called the momentum of the object. Calculate the backward momentum of ejected gases. So we are talking about the ejected gases. Since the momentum of ejected gases is to be calculated, so 0.5 kilogram of fuel and oxygen is being used. So the mass of the ejected gases is going to be 0.5, and the velocity at which they are being ejected is 5000 meters per second. So first I'm writing the formula. The momentum P is equal to mass into velocity. The mass of the ejected gases is 0.5, and the velocity at which they are being ejected is 5000, and the answer would be 2500 kilogram meters per second. So the momentum is 2500 kilograms meter per second for this part. The next part reads, explain what is meant by principle of conservation of momentum. The principle of conservation of momentum is described as momentum of an isolated system remains constant. So the system should be isolated. No energy should be wasted from the system. Then whatever the total momentum is present within the system would always remain conserved and constant. Calculate the increase in velocity of the rocket. To find the increase in velocity of the rocket, we would be using the relation or the formula of impulse, which is the change in momentum is equal to mass multiplied by the change in velocity. Now the change in momentum is 2500 as we calculated in the previous part, and the total mass which is experiencing this change in momentum is 1000 plus zero point 0.5. 1000 is the mass of the rocket and zero point 0.5 is the mass of the ejected gases. So the change in velocity would be calculated here. So change in speed or increase in velocity is equal to 2500 divided by 1000.5 gives us a value of 2.49 meters per second, which in two significant figures would be equal to 2.5 meters per second. So this is how we can find the increase in velocity of the rocket, and the question ends here with this part.